Today we're going to look at using systems using substitution. Now we're going to try solving these systems using substitution. The general format we see that tells us to use substitution is when we have y equals or x equals. Whenever we have a variable that's already solved for, we can plug that in and be able to use substitution. So if I look, I have y equals x minus 4. So I'm going to take this x minus 4 and I'm going to plug it in for that y in the second equation. So let's see what that looks like rewritten. I start off negative 3x, just like I do in the second equation, minus 2. But instead of saying y, I'm going to plug in this x minus 4. So parentheses x minus 4, make sure to close those parentheses, equals negative 2 to finish out that second equation. All right, now I've gone from 2 variables to just 1 variable. So I can solve for x and find the first part of the coordinate for my solution. Okay, to solve for x, I first need to distribute, multiply out that negative 2. So I have negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is a positive 8 equals negative 2. Then I just have to combine like terms and get the x by itself. So combining like terms here, I have negative 3x and negative 2x is negative 5x. Bring down the plus 8 equals negative 2. And now it's just a two-step equation to solve for x. Since it's plus 8, I'm going to have to subtract 8 to get it by itself. Cancels out over here. Negative 2 minus 8 becomes negative 10. And I have negative 5x left on the left side. Divide by negative 5. And x equals 2. So there I've got the first part of my coordinate. Now I can take this x equals 2 and put it back into either of these equations. Since the first equation is already solved for y, I can easily put 2 back in for x and get y. So y equals x minus 4 was the original equation. I'm not going to say y equals 2 minus 4. And then 2 minus 4 is negative 2. So the second part of my coordinate is negative 2. So to relate this back to graphing, these two lines would intersect at 2, negative 2. Okay, so now I'm going to do another problem. I'm going to give you the chance to answer step by step as we go through to practice. So we're going to do negative 3x plus 3y equals 3. And y equals 4x plus 1. So I want to give you a second. Decide what part of these two equations we're going to use to substitute into the other equation. All right, so our identifier here is y equals. Since we have a variable that is equal to something that is by itself, we're going to use this 4x plus 1 in for y in the first equation. So rewriting that first equation, I have negative 3x plus 3. And remember, instead of writing the y, I'm going to put in that 4x plus 1. So times 4x plus 1 equals 3 to finish that out. Now all I need to do is multiply. So I want you to write this, distributing out that 3. So once we distribute out that 3, our negative 3x comes down. 3 times 4x is 12x. 3 times 1 is 3, and I have equals 3 here on the other side. Combining my like terms, I have negative 3x and 12x, so those together give me 9x. My plus 3 comes down, equals 3. Now we just need to get the x by itself. We start that by subtracting 3 on both sides. We get 9x equals 0, and then divide by 9. So x equals 0. Now we take this and plug it back in for x in one of our equations. Since y equals 4x plus 1 is already solved for y, it would probably be easiest to plug 0 in for x in this equation. So again, we started with y equals 4x plus 1. Plug in 0, y equals 4 times 0 plus 1. 4 times 0 is 0, plus 1, y equals 1. So our coordinate point here would be 0, 1. Very good. 0, 1 is the answer.